Okay, my name is Yi Lee, and these are my collaborators. Like many of you, I think you understand the importance of selecting good collaborators. There's many factors involved, but we're going to emphasize today one of those, which is complementarity. Today, we've already heard two talks in which the complementarity between AI and humans has started to show up as a major theme. Now, what we're going to show is that despite the benefits of complementarity, especially in terms of the complementarity between AI and humans, people don't realize that this is important. All right, here we go. Okay, so AI increasingly is becoming a promising collaborator. These days, people are increasingly turning to AI as a collaborator in many consequential fields. For example, doctors are working along with AI to diagnose whether tumor tissue is cancerous or benign. And this tends to improve performance. In a slightly different field, forensic face recognition, whether these two people are the same or different, is another field in which working with an AI seems to benefit more so than working with another human. And let me pick an even simpler case, simply classifying what images are. So take a look at the two sets of images up here. You can have a little classroom participation. Can we say what these images are in the row labeled A?
Croquette.
Very good. Now, this turns out to be the type of image that's very easy for humans, but surprisingly difficult for AI. Now, if I ask you the same answers for B, I'd be surprised if I get many responses, at least many correct responses. Here are those answers for those of you who are particularly curious. Now, the question in a task like this is, how can we make the best teams? Now, to begin with, I can show you that humans are overall better at image classification tasks for images like this than AI are. But the important thing is what happens when we combine them, right? So to review, humans are good at type A, AI are bad at type A, humans are bad at type B, but AI are good at type B. So what happens when we combine two humans? You get a slight bump in performance. What happens when you combine two AI? You also get a slight bump in performance, but you're not even reaching human levels. But when you combine a human and an AI, you get the best outcomes. Now, complementarity is the key to this, right? Humans and AI have different strengths and weaknesses. But the question is, when given a choice between a human collaborator and an AI collaborator, can a human decision maker make the right choice? Can they choose based on complementarity? Now, based on what I've shown you so far, the answer should be yes. Both theoretically, and I'll show you empirically, it is better to work with an AI collaborator who has different strengths and weaknesses as you, rather than another human who has the same strengths and weaknesses as you. Okay? Now, unfortunately, human psychology is going to get in the way here. Let me explain why. Take these type A images, right? This one's an elephant. The humans all can recognize as an elephant, but the AI, for some reason, thinks it's a dog. Now, for you as a human, when you see an AI behave this way, you think, well, that's awfully strange, right? This is so obvious. Right? Anyone can tell that this is a human, unless maybe that person is Russian. Right? So what is going on with the AI? What about this type of image? This type of image, even when I tell you the right answer is chair, you can stare at it for the next hour and you still won't be able to figure out where the chair is. Right? So the fact that the AI can get it right doesn't really teach you much about the AI. Right? I can't understand what the AI is doing. It's ambiguous to me. And so for these two factors, the AI is hard to choose as a collaborator. Whereas the human, well, they get the same ones right as you. And the ones that they get wrong, you cut them some slack, right? It's not that easy of a task. It's not surprising that someone else also wouldn't be able to get this right. Okay. So this makes it so that the AI collaborator seems incompetent and the human collaborator seems like the safer bet, maybe even a more. Now, let me just fill out the rest of this framework here. There's photos that everyone gets right. There's photos that everyone gets wrong. These don't contribute to either accuracy, differentiation, or complementarity differentiation. So we don't really need to talk about them. Okay. So let me test this hypothesis in a series of studies that use the following paradigm. I'm going to show you a series of 10 images, and for each of those images, you're going to classify them. Right? You get a drop-down menu, 16 possible classifications. And for some of these images, they're easy. You can get it right. And once you've made a choice, you find out what the correct answer is, as well as what two potential supporters guessed for this. Now, we didn't tell the participants that these two supporters are in fact an AI and a human. We wanted to avoid any potential AI bias, either for or against. Now, for the type A pictures, these are ones in which humans have an easy time, right? You can tell that it's a car. Supporter A also says it's a car. That's because they're a human supporter. Supporter B, again, unbeknownst to participants, is an AI supporter, always gets these type A pictures wrong. Then you have the type B pictures where you have the reverse relationship. Okay, so that's the basic setup. They do this 10 times, and then they're told, you're gonna do this 10 more times. We're gonna pay you 5 cents for each correct image you classify, and you get to work with either supporter A or supporter B, the ones that you just learned about in those 10 practice trials. Okay, so that's our key DV, and then people actually do those incentivized trials. Now, I'm going to try to show you 5 studies today. They're all using the same paradigm, so they go pretty quickly. And in doing so, I'm going to try to show you evidence for this effect, which we call complementarity neglect. I'm going to try to explain a little bit of why it happens, and we're going to do our best to try to turn it off. Although, as you'll see, it's not that easy. Okay. So first, we're going to just show the basic effect. In this first study, we're going to vary the number of type A and type B studies, type A and type B images, so that the AI supporter, which I'm going to label the complementary supporter here, is either less accurate, equally accurate, or more accurate. And what I'm going to show you here is how oftentimes, when you got the answer wrong, could the AI or human supporter have gotten it right for you? That is, could their advice have been complementary for you? And as you can see, in every single instance, even when the accuracy of the AI supporter is lower, you get higher complementarity from the AI supporter, the complementary supporter. Okay? So this is just a manipulation check. Our study is working as designed. Okay? Now, you would think that this would make it easy to choose the complementary supporter, but instead you find around a quarter choose it when the accuracy of the complementary supporter is lower, a little bit more when the accuracy is equal, and even when the accuracy and complementary are higher for the supporter, still only around 50% of people are choosing it. So what's going on here? Well, I should also add that when you choose to work with the complementary supporter, you perform better, right? Of course, because the other supporter, the one who's non-complementary, is completely redundant. You can't be helped by this because they're only getting answers right when you already know the answer, right? So by design, you cannot very much be helped. Okay. So I started this talk with this AI versus human framing, but I didn't mention humans or AI in the last study. In study 2, we're going to change that. And we thought that adding this label might actually help people make a better choice. Now, the reason for this is that, remember, the complementary supporter makes these choices that are kind of weird. And if I tell you, well, this is an AI, then you're like, oh, okay, I could imagine that an AI would have different strengths and weaknesses than me. Maybe that would explain why they can get these ones right and why they're getting these obvious ones wrong. Okay. Now, everything's the same as in study 1, except that for half the people, we tell them straight up, one of these is an AI model, one of these is a human participant. In addition, for both supporters, we're gonna set their accuracy to 70%, so we're not worried about having different accuracies between participants. And this is gonna be true for all of our future studies as well. Okay. So what happens when we label the AI? It turns out absolutely nothing. Regardless of whether people are working with supporter A or B or human versus AI, you end up with the same complementarity neglect story. People don't seem to understand complementarity, whether it's with humans and AI or whether it's with generic supporter A versus supporter B. Okay, so I've demonstrated the basic effect. Let's delve a little more into why this is happening. So in study 3, we're going to directly manipulate complementarity because it turns out that for those type A images, the ones that humans are capable of doing, some of them are a lot easier than others, and some are actually pretty hard. So in a control condition, we're going to keep using all of these easy type A images, the ones that humans have no problem with. In a second condition, we're going to set it up so that you have actually very hard type A images. And this has the effect of both making the human supporter more complementary, and it makes it so that when the AI supporter gets those ones wrong, it doesn't seem so bad. It's possible that you wouldn't be able to guess this because it's hard. It's hard for humans as well. Okay. In addition, we're going to directly measure people's perceived competence. That is, how skilled, competent, and capable do you think each of these supporters are? Okay. So just to show you this manipulation works as intended, the number of times you can be helped by the complementary supporter for the easy ones is very high versus complete redundancy for the non-complementary supporter. But now, when the type A images are hard, you also get some benefits. Paradoxically, by increasing the complementarity of the less complementary supporter, you actually reduce choices for this. So there's something very difficult about working with a complementary supporter. Instead, what it seems that people are doing is deciding that competence is what matters. Okay, so here we have the perceived competence ratings. You can see that when the images for type A are easy, the human-like supporter is rated much higher than the AI supporter. When those type A images are also hard, you get no difference in competence. And it turns out that this perceived competence score actually fully drives people's choices. Okay, so we have some understanding what's going on here. Let's see if we can try to put more emphasis then on complementarity, right? If people are focused so much on competence that they're failing to see complementarity, let's just emphasize it a little more. Let's draw more attention to it. We're going to do this in two ways. The first is that we're just going to directly ask people to rate how much this supporter can help you on the task that you find difficult. Draw attention to it. Half the time we ask the questions before people chose, and half the time we ask after. So if we ask it after, it can't have an effect on choice. That's our control condition. If we measure it before the choice, complementarity is on your mind. Now, we also added a third condition in which we showed everyone a results table so that you have an objective understanding of just how well each person did. Okay, so let's see what happens. We start with our complementarity and neglect effect replicated again. If we ask about complementarity, we increase the percentage of people choosing the more complementarity supporter. However, still less than 50%. If we further add this table, you end up finally getting over 50% and significantly so. Now, that should be something to celebrate, but at the same time, what's going on with the other 40% of the people? Why is it that there's a stubborn 40% who still choose to work with the completely redundant, non-complementary supporter? This is what we're going to look at in study 5. Right? If we just can't get through to these people, would it work to just assign those people to work with the complementary supporter? Right? Can we just sidestep the choice? Right? This is something you could force in a work situation. So very straightforward design. Either people get a choice or they get assigned to one of these supporters. Right? As usual, you find that people prefer the less complementary human-like supporter. But when you directly assign people, what happens? Well, let's look at their performance. In terms of performance, you see that being assigned to work with a complementary supporter actually does increase your performance relative to being assigned to work with the non-complementary supporter, but it's not as good as if you directly chose this. Okay. Let's delve a little deeper into why that's happening. This is the percentage of people the number of errors people make as a result of not following correct advice. You can see that even when people choose to work with a complementary supporter, they're only listening to them about half the time. But over here, when they're assigned to work with them, you're only listening to them 25% of the time. So you can't force someone to work with a complementary supporter. It causes them to rely on them less. there's no difference in terms of errors due to following incorrect advice. Okay. So I'm a little over time, so let me just wrap up. Despite the benefits of collaboration with a complementary partner, most people fail to capitalize on complementarity. It's difficult to recognize in the first place. People seem to instead look at perceived ability. And you can try to turn this off a little bit by emphasizing complementarity, by showing people, indeed, this one person is more complementary than the other. And you can even try to assign them to a complementary partner, but you just don't get all the way there. So this is definitely ongoing research. Here's a link to the slides, and I'll be around for the rest of the conference. And I would love to hear your feedback.
You can probably do one question.
Fascinating research. I was just curious, have you thought about flipping the question and asking AI if it want to work with a complementary human?
I think that the AI will probably be smarter about it, but I have to check. Thank you.
There's actually a nice paper in information systems research that looked at humans doing a task and delegating to AI when they're not sure, AI doing a task and delegating to humans when the AI is not sure. And they showed that AI is better at delegating when it's not sure, whereas humans don't know when they don't know, so they delegate at the wrong times.
And they're overconfident. So this actually relates back to the first paper, where that confidence measure is something that an AI naturally comes up with, right? But humans don't. Humans are overconfident about how much they know. All right, thank you, everyone.
There's a 15-minute break right now.